We got a square matrix A of size 3 by 3. We want to find the inverse of A and solve the system of equation. Once again, we got A equal to this matrix with first row 2 minus 3 5, second row 3 2 minus 4, and third row 1 1 minus 2. It is a 3 by 3 matrix. We want to find the inverse of A. We will find it by computing the cofactors and then cofactor matrix. C11, C12, C13. These are the cofactor corresponding to A11, A12, A13. Now we simply change the sign alternatively, plus, minus, plus. After that, if we want to find C11, the cofactor corresponding to first row and first column, what we do is we simply cover up the first row and first column. When we do so, we are left out with the entries 2 minus 4, 1 minus 2. Once again, we are left out with the entries 2 minus 4, 1 minus 2. Let us write those entries. 2 minus 4, 1 minus 2. Now, we just determine this determinant whereby anti-clockwise direction we regard it to be positive and clockwise direction is regarded to be negative. We get minus 4 plus 4 and that is 0. How about C12? That's corresponding to first row and second column. So we cover up first row and second column and we are left out with 3 minus 4, 1 minus 2. 3 minus 4, 1 minus 2. And that's equal to minus 6 plus 4, that is minus 2. But we got one more minus, so plus 2. C13, just cover first row and third column. We are left out with 3, 2, 1, 1. 3, 2, 1, 1. That's equal to 3 minus 2. 3 minus 2, which is 1. Okay, we did determine the cofactors for the first row. How about for the second row? We did C11, C12, C13. Let's find C21, C22, C23. We need to change sign alternatively, plus, minus, plus. So now plus, minus. So minus, plus, minus, plus, plus, minus. Okay, minus, plus, minus. Are we changing the sign alternatively? The answer is yes. C21, that is corresponding to second row, first column. Second row, first column. Let's cover those up. We will be left out with minus 3, 5, 1, minus 2. Minus 3, 5, 1, minus 2. That's equal to, again, anti-clockwise direction positive, clockwise direction negative. So 6 minus 5, which is 1. But we got negative, so minus 1. Let's cover up second row, second column. We want to find C22. We cover up second row, second column. When we do so, we are left out with 2, 5, 1, minus 2. 2, 5, 1, minus 2. That's equal to minus 4 minus 5, which is minus 9. Now we cover up second row and third column. We are left out with the element 2 minus 3, 1, 1. Let's write that. 2 minus 3, 1, 1. Again, anti-clockwise direction positive, clockwise direction negative. So 2 plus 3, which is 5, but we got minus outside of the determinant. So we get minus 5. Okay, we did compute C21, C22, C23. Lastly, we compute C31, C32, C33. For determining C31, we cover third row first column. When we do so, we are left out with minus 3, 5, 2, minus 4. Minus 3, 5, 2, minus 4. That's equal to 12 minus 10. 12 minus 10 is 2. Oh, we should check the sign as well. Plus, minus, plus. Minus, plus, minus. Plus, minus, plus. Okay. C32. Third row, second column. We are left out with 2, 5, minus 3, 4. 2, 5, 2, 5, 3, minus 4. Third row, second column. 2, 5, 3, minus 4. Okay, minus 8, minus 15. That's equal to minus 23. But we got negative outside as well. So we get plus 23. Let's write comma just to separate the entries. Lastly, C33 just cover third row and third column. Third row, third column. When we do so, we are left out with 2 minus 3, 3, 2. Let's write those elements. 2 minus 3, 3, 2. 4 plus 9, that's 13. Okay, we did compute C11, C12, C13, C21, C22, C23, C31, C32, C33. Now, what we do is we write the cofactor matrix. Cofactor matrix is given by, we just need to copy those entries C11, C12, C13, 0 to 1, 0 to 1. Next, C21, C22, C23, C21, C22, C23, minus 1, minus 9, minus 5, minus 1, minus 9, minus 5. Lastly, C31, C32, C33, 2, 23, 13. Okay, we did determine the cofactor matrix. Now, adjoint of A. When we interchange row with column and column with row of the cofactor matrix, we get adjoint of the matrix. 0 to 1, that's the first row. We write it as first column. Minus 1, minus 9, minus 5, that's the second row. We write it as second column. 2, 23, 13, that's the third row. We write it as third column. 2, 23, 13. Okay, we did determine the adjoint of A. Now we want to find inverse of A. A inverse is defined as adjoint of A by determinant of A. Once again, A inverse equal to adjoint of A by determinant of A. We simply write it as ADJA, that's adjoint of A, and then we need to divide by determinant of A. Okay, now how about determinant of A? Determinant of A can simply be determined from the cofactors. And the first, or rather, determinant of A can be determined using the first row and cofactors of the first row. 2 minus 3, 5. That's the element of the first row. Let's write that. 2 minus 3, 5. When we multiply the element by the cofactors are 0 to 1, 0 to 1, and then add it, we get the determinant. Well, minus 6 plus 5, that is equal to minus 1. We could have multiplied second row with the cofactor of the second row. We'll get the same answer. Okay, we got determinant turns out to be minus 1. And so A inverse equal to adjoint of A divided by determinant of A, that's just minus 1. Adjoint of A is actually in this case negative, or rather A inverse in this case turns out to be negative of adjoint of A, and that's equal to, just change the sign, 0, 1, minus 2, minus 2 plus 9 minus 23. 1, minus 1 plus 5 minus 13. Did we change the sign? Yes. Did we change the sign? Yes. Did we change the sign? Yes. Okay, we did find the A inverse. Now, the question says if A equal to this, find A inverse and then solve the system of equation. Observe that coefficient 2, minus 3, 5. Coefficient of x, y, z are 2, minus 3, 5. 3, 2, minus 4, 3, 2, minus 4, 1, 1, minus 2, 1, 1, minus 2. Okay, A is just the coefficient matrix of the system of equation. And the system of equation can be written as A multiplied with the column matrix x, y, z equal to column matrix 11 minus 5 minus. Okay, if we multiply by A inverse from the left, then we get x, y, z equal to multiplication of A inverse with 11 minus 5 minus 3. We're simply saying that if Ax equal to B, then x must be equal to A inverse times B. Is there anything great about it? No. So we just need to solve for x, y, z, and we can do it by simply multiplying A inverse with this column matrix. Do we know A inverse? The answer is yes. We did compute A inverse and it turns out to be 0, 1, minus 2, 0, 1, minus 2, minus 2, 9, minus 23, minus 2, 9, minus 23, minus 1, 5, 13, minus 1, 5, 13. Multiply that with the column matrix 11 minus 5 minus 3. Now, if we want to find x, y, z, we simply need to multiply this matrix with this. And we know how to multiply. We just multiply row with column. So 0, 1, minus 2. That's the first row. Multiply it to the first column. 11 minus 5 minus 3. Again, multiply second row to the first column. Minus 2, 9, minus 23. Multiply it to the first column. 11 minus 5 minus 3. Lastly, we got third row, minus 1, 5, 13. Multiply it with the first column. 11 minus 5 minus 3. Okay, now we just need to compute those values. 11 minus 5 is 6. Sorry. 6 minus 5 is 1. 69 minus 22 minus 45 plus 69, and then minus 11 minus 25 minus oh, this is minus 13. So we got minus here. Minus 11 minus 25 plus 39, which turns out to be 1, 2, 3. And so x must be equal to 1, y must be equal to 2, and z must be equal to 3. And we did solve for x, y, z.